move to the presentation of Stef Proost on aviation.
Thank you. My voice may be a little bit suboptimal, given that I just had a cold. Okay. Now, I think aviation for the Minister of Transport in France is already a very important topic, and I think I see regularly coming these, so I will not discuss France, I will mainly discuss EU and more than EU. Now, whenever we discuss aviation, it's important to make a distinction between, I would say, 4 categories of emissions. So overall in the world, aviation counts for something like 3%. It is growing, that's clear. It's a source of concern. Now, what I will do is discuss, first of all, emissions of basically greenhouse gases within the EU, the first column. Then discuss very briefly, so why to make this distinction, because actually Paris is in agreement to deal with emissions within a given territory. And of course, everything which happens between different countries, who is responsible? They needed some kind of, in the case of air transportation, they needed a second kind of agreement, and that's the CORSIA agreement. Okay, come back to that in a moment. So each of these categories have their own issues. I will mainly discuss the EU and maybe EU to the rest of the world. There's an extra issue which is neglected in many circles. Those are the non-CO2 greenhouse gases. That could be as important or twice as important as the CO2 emissions. So we should not forget that, and it's something we will discuss in a moment. I have no theoretical models today. Anyway, I will try to address 5 policy questions. And by the way, I like people that disagree with me. So I will try to be very blunt in the answers I give to these 5 questions, okay, and see what type of response that will generate. The first question will be about EU ETS. Does it work? And I think apparently we had already some debate on electricity, so it's interesting to launch that debate. That's number 1. Number 2 will be on issue of what are called drop-in sustainable aviation fuels. Is there some kind of miracle solution by using fuels from biological origin, and that could reduce emissions in the air transport sector? Then the third one is this CORSIA agreement on international aviation. Will it work? Then I will try to advocate a little bit more trying to push more efficient airplanes, and I will conclude with how to deal with associated non-CO2 greenhouse gases. Okay. Sometimes I start with a quiz, but I think there are so many economists in the room, and I used to have this quiz with my colleagues at the university. I was responsible for a certain number of years to come up with a more consistent answer of the university or across disciplines about how to deal with climate change. And you can read the quiz. Usually it's the quiz for politicians and academics of other disciplines, not for economists. So if I replace my flight Paris to Vienna by a train journey, will this increase or decrease emissions of CO2 in Europe? Then I immediately have all these people who specialized in physics and chemistry, whatever. They start computing, and I got this source and I got that. And they tell you, yes, of course, it's better to take the train. Unfortunately, the answer is very simple. Both. So whenever you fly inside Europe, you need to buy permits to emit CO2. And so you can turn around the question in very different ways, but it's the net effect, whether I take the train, taking the train rather than to fly, the net effect on CO2 emissions is 0. That's a very important point that is not yet very well understood. I'm not sure whether the French Minister of Transport understands this, but this is an important point. There's an exception. These are the other gases than the CO2, and we'll come back to that in a moment. Now, is it true? Does it work? A lot of people say, yes, ETS, but people don't notice this. People don't know this. Aviation companies, they have no clue. Of course it works. It has an impact on the cost. Whenever I have to pay a higher fuel cost, it will work. And there is very clear evidence by Fageda and Exido. They looked at this question using, I think, good econometric techniques. And their answer is actually very clear. It works. Even, and then there's another point, so these ETS, these permits were grandfathered. What is grandfathering? Grandfathering means that I observe your consumption during a given year in the past. And in function of that consumption, you get credits, and you get maybe only 90% of the consumption you used before. But the fact that they are given is still, it still keeps working. It's not because you get them for free that it doesn't work, because they have an opportunity cost. You can sell them to somebody else. You can sell them to another sector. So that's the important driving force, and that makes that even grandfathered permits may work. And I think it works in many, many, many circumstances. Of course, it will work more easily for those links. If I have a good link, I'd say Paris-Brussels, excellent rail link. Of course, aviation, there will be much more substitution between aviation and rail in these sectors than on a link between, I would say, Paris and Toulouse. Is still very bad to take the train. So, okay. And in addition, it has a larger effect on the low-cost airlines. So that's an answer to the French Minister of Transportation. Okay, so that's question number one. Question number two is very fashionable, and I think the EU makes here a mistake. EU believes, and many other countries believe, in the sustainable aviation fuels. What are the sustainable aviation fuels? It are fuels actually that comply with what is called sustainability criteria, no food substitution, no biodiversity degradation, but in principle they're carbon-free because they start from a biological origin. It's actually carbon that has been growing, okay, in the trees, in plants, whatever. In fact, they're not carbon-free. Very often, if you look at the net emissions, you still have to collect the trees, you have to treat them. So, in fact, it's very often emissions can be 50% to 80% of the CO2 of kerosene. Now, an advantage that they are drop-in fuels is just like we also use them for cars. So we had biodiesel, biogasoline, things like that. So you can just keep using the current aircraft technology. You still have the same distribution infrastructure in the airports. And actually, it's important there to make a distinction between two types, those based purely on biomaterial. So you have some biomaterial, you convert it into liquid fuels using different processes. Now, they're costly. These biofuels cost you maybe 1, 2, 4 times more than the price of kerosene. And supply is limited. So that's an important limitation on the quantity. Now, what is the future? Could be what is called e-fuels, fuels based on electricity, where you try to combine green hydrogen together with CO2 that you capture. You need to add some carbon to the hydrogen to get substitute fuel. It's even much more costly. It's 3 to 6 times the price of kerosene. What argument pro, and then I start to read all these assessments by the Commission. They say it's needed because aviation has to do its fair share. So it's the idea that if you want to reach net zero in 2050, implication is almost that all sectors have to reach net zero in 2050. Of course, that's a mistake. We don't have to reach zero emissions. It's net zero emissions that is needed, and there's something very, very different. Was a second point that is a little bit strange to find in some kind of cost-benefit study, is that the current prices of kerosene, including ETS permits, are insufficient to pay for the supply cost of SAF. Now, of course, yeah, you could also say SAF is just too expensive. Now, I think my main argument contra is given by this very small computation. What I did in this computation is just compare. We want to reduce emissions by 25% using either a blending rate, where you say, okay, fuel has to be blended in order to reduce emissions. And the alternative is to use a permit price of €100, which is about close to the present ETS price. If you make the simple computation and you assume that the SAF is carbon neutral, but that's a very strong assumption to start. In addition, it costs only twice as much as kerosene. You end up with a welfare cost that is 3 times higher if you use SAF than when you just use simple ETS system. But that's the main reason why actually I'm not at all in favor of SAFs. SAFs can be a solution if they come up and became much more cheaper. Okay. Let's just continue with using permit prices in aviation. Whenever you look at emissions by the aviation sector, there is, in fact, we think, yeah, Europe is important. No, Europe is a small share of the aviation market. I think just flying to other continents emits much more. Flying from EU to other continents is much more important than what we do inside Europe. And of course, the rest of the world is growing much quicker than we are. And that means that we have to pay attention to the CORSIA agreement. What is this CORSIA agreement? CORSIA agreement tells you that whenever you sign the agreement, what you do is you agree to stabilize emissions for the bilateral flights. Okay, so that would be a way to actually stabilize emissions, avoid more growth. Now, what is problem is that basically anything is accepted to stabilize these emissions. And there is a problem. So first thing is what is called offsets. You can compensate it by another way of reducing emissions in your economy. But, you know, there's this market for offsets, official markets for offsets. You could buy offsets of 1 ton that cost less than €10. So it's probably, I don't believe that this can be done. Okay. The second assumption, and you will see that they really count on the technology of the SAFs. If a SAF, the emission of SAF is only 90% of the kerosene, it's accepted as carbon-free. Cannot work. If you look at the criteria in CORSIA, they're extremely lax. And I consider that more for the moment as window dressing. It's not serious. is actually what you see in the official publications of CORSIA. Official publications of CORSIA, you see that these job. Sustainable aviation fuels will do the job. I think there's something very wrong. It will not work. Okay. Therefore, I plead very often for an extra effort to have more efficient airplanes. This is the market for airplanes. And France, Toulouse, okay, you are headquarters of Airbus, okay? Boeing is the other main producer, so you have a duopoly that is very important, that produces 90% of the aircrafts. And you could say, if we could do something with these two players and make sure that we come up with better aircrafts, you could, in a very indirect way, also affect the world. So if you look at here, so this rest of the world, of course, there is the US in the rest of the world, but you have an enormous multiplicator effect. We are, for the moment, the ones producing the solar cells, or the photovoltaics. You could see it in this way. If we could make these photovoltaics less expensive, we could indeed have a very large effect on total emissions. Now, this is an illustration of the net emissions over time per flight kilometer. You see that over the last 20 years, there's already a very strong decrease. I think that can be improved. Will it work? It's a little bit complicated story. You have a duopoly that is competing. You have several governments that are competing. But to make my story short is that I think you can still do a lot if the rebound effect is limited in the rest of the world. What does it mean? It would mean that in the rebound, to limit the rebound effect, what you need is some extra tax, a permit price on CO2 emissions also in the rest of the world. Of course, things would get much simpler if also the US joins Europe to do something and also makes an extra effort to reduce emissions on top of what they expect as the normal kerosene price. Final point, how to deal with non-CO2 gases. First thing, they exist. They're no joke. Okay? I think there are very serious studies by atmospheric scientists that these are important. How important they are depends on what perspective you take. The global warming perspective, you say, I only consider the first 20 years. They affect the first 20 years because they are short-lived. They are relatively more important. What if I say I take a horizon of the effects on 100 years, they become a little bit less important, but they're still very important. How are they dealt with? CORSIA neglects them, say, needs to be studied. The EU says, we need further study. And I say, if you see the document, how much time will it take to come up with a policy or position? Maybe 8 years. Okay, look, 8 years is a long time. Now, what is important is that it has very strong policy implications. Whenever you realize that burning fuel in the air has a larger effect than just burning the same fuel at land level, it means that you cannot compensate it via simple offsets or via simple ETS. There's no correct compensation. So if we want to compensate emissions of kerosene in the air by less emissions on land level, it's just not 1 to 1, it's 1 to 1 to 7. Okay, 1.7. There's another implication, is that the SAFs, even if they are carbon-free, are still worse than more fuel efficiency of airplanes. Because what you do is you produce a fuel, maybe in a carbon-neutral way, but you start burning it in the air, where it still has a net global warming effect. Okay? So we have to be very careful in the way we deal with this non-CO2 gases. I'm going to be quiet because my voice is about ending this capacity. I'll let you read the summing up. Thank you.
Thank you very much for the presentation again. Are there questions from the audience?
Just a question. I don't understand the quiz, the first quiz at the beginning of your presentation, because I don't understand how you can consider that it's the same to travel by train and by airplane, considering pollution.
So it was good to raise the quiz. To raise the quiz anyway. I understand now. Okay. What is the point? The point is that, anyway, you need a permit to produce electricity to make the trains drive, okay? You also need a permit for aviation. The fact that the total emission is capped, the total number of permits is limited. Whenever I substitute an activity that uses a lot of permits by an activity that uses less permits, does not change the total cap. I'm not sure, you're an economist? No, but this is one of the few things an economist can tell you. All the rest we have to learn from somebody else.
Yes, but all the IPCC scenarios don't consider permit to pollute.
So the other IPCC, but I think IPCC, of course, there was already, I think Christian already didn't like IPCC on some points, but it's clear that a permit works like a carbon tax. It puts a price on emissions. And it puts the same price on emissions wherever the source of emissions. And that makes it an efficient instrument. But I don't know, Christian, you want to?
I wanted to first to congratulate you, because it's very hard to go against, the general mood of using norms and this blending issue of the kerosene, and explaining that having the carbon pricing mechanism would make life much better and generate the same outcome with a smaller total cost. So I wanted to congratulate you on that. One of the difficulty of the field of the sector is that there is so few tax on kerosene compared to gasoline at the pump, for example, that it had generated this fly bashing issue that could one day. I mean, and in a sense, that's the sector fault of getting this protection. These heavy lobbies that maintain the tax so low in the sector now is striking back against the sector. In a sense, that's a good part of the story. But yes, so it's good to remind people that having carbon pricing rather than imposing norms. And when you say the aviation should do its part of the decarbonization, you are right to say that that should be optimized, and the share of the effort of the sector compared to the other sector depends upon the relative marginal abatement cost. I agree with you. I have for the e-fuel, I have information that using e-fuel, using e-fuel would increase the cost by a factor 5. But the problem is the share of the fuel in the total price of airline transportation is only 20%. So if you multiply by 5 the cost of 20% of the total, it has an effect on the total price, but not so much. So the price elasticity, yeah, that's a nice table, but the price elasticity is not so important for the outcome.
It's very hard. So it's very often I've been advising the European Commission. They didn't believe me. They didn't accept our report. I don't know why. I did it 5 years ago. I say it's not good stuff. SAF should be very careful. I think the lobbyists were much stronger than I did. So the problem here, if you look at these data, is that the risk is indeed that you accept a policy that is much more for society as a whole, is much more costly than a simple permit or than a simple tax. And of course, if I would be an aviation company, I would say, okay, look at if I'm an aviation company, it's clear that the total effect on the volume of aviation will be much lower with my SAF policy than with my permit policy. And that drives the lobbying. And that, I think probably it happens in many sectors. So you can also, so it's not very different from the idea that, for instance, renewable energy has to be 50% of the total power generation. A little bit the same story. These ideas come back, and as economists, we have to try to convince people that this is not correct.
And the point is in the newspapers these days in France is that they will not impose a carbon price on top of Corsia. In France, they will tax profits of the airports, which is completely crazy. And again, I mean, it would be so much easier to impose a uniform carbon tax for emissions rather than having these sectoral policies, each time the government having to strike a negotiation with the sector with relatively strong lobbies, and that will determine the outcome, and the global outcome will be very far from the efficient solution. So that's a crazy part of a common and controlled solution compared to carbon pricing. And I'm happy to, this table, I like it so much. That's a clear demonstration of the problem.
Thank you.
Last question.
Thank you. Maud de Villeneuve, I'm a PhD student in Cergy. I would like to go back to this issue of carbon leakage, if that's okay. So maybe it also involves Robin talk in Frank's talk as well. Because it's a very interesting question to me. And I was wondering whether we should think about the fact that we have very low evidence of carbon leakage as being a way to show that, okay, the EU ETS works well, instead of thinking about it as we don't have high carbon leakage because the EU ETS doesn't work well. So it doesn't incentivize firms to perform carbon leakage. So like, in other words, because the EU ETS provides so many permits, probably too many permits, then it doesn't end up into high carbon leakage. Maybe if the EU ETS worked better, I'm not saying it doesn't work right now, but maybe not optimally, then we would have higher carbon leakage. So it doesn't eliminate completely the potential for future carbon leakage, the fact that we don't have carbon leakage today.
I think it's more like a technical question. Actually, probably you're alluding to the allowance of free permits to the steel industry or to a couple of industries that are very energy intensive, and that this avoids, to some extent, carbon leakage, so that we buy too much steel from China or India, whatever. Now, okay, as such, it's a policy that is really second best. It would be better to have some kind of border tariffs or some kind of other mechanism to avoid carbon leakage. But for the moment, there is not so much carbon leakage. As such, I think the policy works. I think, but Frank knows more about this than I do.
So does it work? The answer is clearly yes, in the sense that emissions in the EU ETS have reduced by almost 30% now. That is faster than the non-ETS emissions. Now, that is not only causal. So I think, we did one of the last causal estimates for the early periods. We were around 10% in the two early phases of reductions. So it is, I would say, one of the best policies or most hopeful policies there is, in the sense that it works. Now, your question is relevant because the start is easy. So we switch from coal to gas, things like that. So now the second part is going to be harder. We need to go like hydrogen steel and things like that. The risk of leakage is considerable. Then, the general answer is the carbon adjustment tax. Now, it comes with quite a few legal issues, but also economical issues, an incentive to assemble abroad, for example, rather than import carbon-intensive raw materials. So the jury is still out. We're going to see what it gives. There will be probably a bit of messy policy going on also, but for now, the leakage is very small, despite large, 25%, 30% reduction of emissions. I can call it small or big, but I would rather call it big.
Thank you very much.